Hello everyone, I am Professor Deepika from Vidya Institute of Technology, Department of Electrical and Electronics. So in today's video, I'm going to discuss about the derivation of trapezoidal and quadrilateral curve with respect to the traction system. So you can see the PPT here. So first of all, we are going to study about the calculations of trapezoidal speed time curve. So the speed time curve is that it is a curve. It is the curve, and it is the plot between speed and time. And this is with respect to the train system. That is, usually the train traveling system will be, or the train service system will be classified into two types. One is mainline service, and the other one is called suburban service. So in the mainline service, we have got to know that the coasting period will be, the free running period will be more. That is, the accelerating period will be there, and the braking period will be there, and the coasting period is almost reduced. That is, the coasting is nothing but what? The period where the power is cut off and the train is allowed to run under its own momentum. So that period will be usually less, and the free running period, that is this the power drawn by the system, will be almost constant. So that system is called as mainline service. That is, the distance between the two stations or the two stops is more. So that is nothing but the mainline service. So that mainline service curve can be simplified into a trapezoidal form of curve. And about the quadrilateral curve, so that is belongs to the suburban service, where the stops between the two station is almost small, and the coasting period will be more over that. So that is nothing but the suburban service. Okay, so for that curve, usually it is simplified in the form of quadrilateral curve. So now we will study how actually the derivation of this trapezoidal speed time curve goes on. So this is actually the curve what we are telling here. So this OA is nothing but the acceleration period, and AB is nothing but the free running period, and B is B, or something like, if I take some G, then this will be called as a braking period. Okay, so this is with respect to the trapezoidal curve, but this trapezoidal curve is extended in both the mean. That is, the AB curve what you can see, so this will be turned into a DF curve, so that we will get the proper geometrical curve in the form of trapezium or trapezoidal. So this is nothing but the curve approximation. That is, the AB curve, that is, here you can see this this braking period is enlarged. You can see here, so this is enlarged to F, and this is almost reduced to OD. So therefore you will get the proper geometrical curve, which is called as the trapezoidal curve. And for the derivation, I am going to consider only the trapezoidal curve, that is the simplified form of curve. You can see here ODFC is nothing but the trapezoidal curve, which is the speed time curve for the mainline service of the train system. Okay, so here, as I told you, ODFC is the trapezoidal curve, and here you can see on the y-axis we have marked the speed, and in the x-axis we have marked the time. So therefore this is the speed time curve. Okay, and here OD is nothing but the acceleration period, which is called as the time T1, and DF is called as the free running period, which is nothing but T2, and FC is nothing but the braking period, which is called as T3. And now this total curve, we call it as, this total period is called as time of run, that is the capital letter T. And here you can see this is the OKLC curve what you can see. So this is the average curve, this curve is used to calculate the average speed of the train. And here VM is nothing but the maximum speed which is attained by the train. Okay, so these are the terminologies which are used in the trapezoidal speed time curve. So now let OABC is nothing but the actual speed time curve. You can see here OABC is nothing but the here C term is missing. OABC is nothing but the actual speed time curve, and now ODEFC is the equivalent simplified curve or called as trapezoidal curve. Trapezoidal speed time curve ODEFC can be further replaced by rectangular speed time curve OKLC. Here the height of this rectangle will gives you the average speed over the run. If I again simplify this ODFC trapezoidal curve, then we can actually obtain the average speed time curve. The area under or the height of this rectangle will gives you the average speed. So now I have considered this thing. So the same thing what I explained over there. So now I'll denote one by one term. So let alpha is nothing but the acceleration in kilometer per hour per second. So this is the unit for acceleration, that is the alpha. That is the train has to accelerate from the state of it rest. Okay, so therefore alpha is nothing but the acceleration in kilometer per hour per second, and beta is the retardation. That is after attaining this point, that is after the train has attained its has attained at the end of its free running period. So this FC is called as the retardation period. That means what? The brake will be applied to the train, so therefore the speed is going to reduce, and at the C point the train will be comes under a rest. So therefore the braking also has to be applied. So therefore beta is nothing but the retardation in kilometer per hour per second, and VM is nothing but the crest speed, or we call it as maximum speed in kilometer per hour. So the speed unit is kilometer per hour, and the acceleration and retardation unit is kilometer per hour per second. And T is the total time of run in second. You can see here. So this is the total time of run. That is the total time required by the train from the starting station to the ending station. Next, now how do I calculate the time t1? So we know that acceleration is nothing but speed by time. So therefore, to calculate the acceleration time, it is nothing but speed by acceleration will gives you the time for acceleration in second. And what is the time for retardation in second? Because if I know the retardation, then it is nothing but Vm by beta. Then time for free running in second, that is the time t2. So you can see here, this is the total time of run. Usually the total time of run can be calculated, because if I use the stopwatch, if I use the watch, and if I start it from the starting station to the ending station, then I can actually calculate the total time of run. Therefore the time for free running second, or I can say in this way, the total time of run t is nothing but what? It is nothing but t1 plus t2 plus t3. So now how do I calculate t2 then? T2 is nothing but t minus of t1 plus t3, or I can say t minus of Vm by alpha plus Vm by beta. And what is d? D is nothing but the distance between the stops. So don't confuse over here. This d is only the notation, and this d is nothing but the distance between the stop. And what is the VA? VA is nothing but the average speed in kilometer per hour. So how do I calculate VA? VA is nothing but what? That is speed is nothing but what? It is nothing but distance by time. I know distance, so I can substitute over here. Time is nothing but what? It is the total time of run, which is nothing but t. And you can see over here, this t is in second. If I want to convert into hour, then what I have to do? I have to divide t by 3600. So therefore, at last what I'll get on simplifying, it is nothing but 3600 d by t. Then I can actually donate d or s. So how do I calculate this d? So it is nothing but what? It is actually nothing but the distance traveled during acceleration, distance traveled during free running, and it is the distance traveled during braking. If I sum all these distance, then I will actually get the total, I'll get the distance traveled during the whole thing. But usually how do I calculate this d or s? Means what? It is actually nothing but area of trapezium, that is ODFC. So why I have simplified the curve into trapezium? Because the trapezium is nothing but the proper geometrical figure. If I calculate the area under that curve, then I can actually calculate the distance between the two stops. If I had that that is the other figure, that is before simplified figure, I can't actually calculate the distance because it is not in proper geometrical form, and I can't actually calculate the area under that curve. So if I reduce that curve into a proper geometrical figure, then I can actually calculate the distance, then I can actually calculate area under that curve. So therefore, I have reduced that curve into a proper geometrical curve. So therefore, what is actually the area under that curve? Area under that curve is nothing but it is the area under the trapezium, which is nothing but the total distance between the two stations. So I can actually reduce this trapezium into three parts. You can see here I can actually reduce this trapezium into three parts. One thing, that is two right angle triangle. You can see this is one right angle triangle, and this is one right angle triangle, and this is nothing but the and this is nothing but the square, and this is nothing but the rectangle. So therefore I can reduce this trapezium into again three geometrical figures. So one is area of ODG. So the area ODG is nothing but what? It is the distance traveled during acceleration. So therefore it is the area of triangle ODG plus area of rectangle is nothing but GDFH, and this is the FHC. FHC is nothing but area of triangle, or area or it is the distance traveled during breaking. Okay, so if I sum all these three things, then I can actually get the distance between the two stations. So you know that what is the area of triangle? Area of triangle is nothing but what? It is the half into base into height. So area of triangle is nothing but half into base into height. So therefore I can use this formula for the calculation. So you can see here, this is the area of triangle ODG. You can see here. So this is the area of triangle ODG. So half into base is nothing but what? It is nothing but OG. OG is nothing but what? It is nothing but T1. So T1 is nothing but what? It is the time traveled during acceleration. So therefore, what is T1? It is nothing but Vm by alpha. Correct. First of all, we'll write T1 as it is. Okay, so it is nothing but T1, but it is in second. But I have to convert T1 into hours. So therefore, that is the standard unit over here. So therefore, T1 should be divided by 3600 to convert second into hour. Okay, so therefore the base is nothing but T1 by 3600. What is the height over here? You can see this is the height of the triangle, and what is that? That is nothing but the Vm plus what is the area of rectangle? Rectangle is nothing but what? It is the length into breadth. Okay, so if I say the length, it is nothing but the T2, which is in second, but I have to convert that second into hours. So therefore I have to divide by 3600. This is the length, and what is the height or width? It is nothing but the height of the rectangle, which is nothing but again Vm. Okay, next, what is the area of this triangle? It is nothing but FHC, which is nothing but half into base into height. So what is base here? It is nothing but T3. T3 divided by 3600 will give you the base, and what is the height over here? Height is nothing but the Vm. So in this way we can calculate the distance, or we can actually calculate the distance between the two stations. Now I'll take Vm by 3600 as common. So if I take Vm by 3600 as common, then what I have written over here, that is half T1 plus T2 plus half into T3. So this is the thing. Just a minute.
So if I take Vm by 3600, then I left out with half T1 plus T2 plus half into T3. Okay. So next what I'll do, so I know that T is nothing but T1 plus T2 plus T3. Correct. I know T is nothing but T1 plus T2 plus T3. So therefore what I'll do is, I'll take half common from this term and this term. So therefore I'll retain with T1 plus T3, and I'll replace T2 by T minus T1 plus T3. You can see here what is T2. T2 is nothing but T minus T1 plus T3. So therefore I have replaced that term. Next, so therefore what happens? So therefore what happened, this is half into T1 plus T3, and this is minus of T1 plus T3. So therefore half minus 1 is nothing but what? It is nothing but again minus half. So therefore I left out with T minus half into T1 plus T3. So next, I'll replace T1 plus T3 by their respective term, that is T1 is nothing but Vm by alpha and T3 is nothing but Vm by beta. So next what I'll do is, so I'll cross multiply this term, that is D is equal to this term I'm having. Upon cross multiplying, I'll get 3600 D, and I'll multiply or I'll take Vm common, and I'll multiply this Vm by and I'll multiply Vm inside. So therefore what I'll get is T into Vm minus half Vm square into 1 by alpha plus 1 by beta. Now I'll assume that 1 by alpha plus 1 by beta as k. That is some constant that I am assuming that 1 by alpha plus 1 by beta is nothing but k. So therefore I'll substitute 1 by alpha plus 1 by beta as k. So next, half into Vm square k, I'll rearrange the term, that is half into Vm square k minus T Vm plus 3600 D. Now I'll multiply 2 with whole term. So therefore Vm square k minus 2 to Vm plus 7200 D is equals to 0. Now you can see this equation. It is a quadratic equation in the form of Vm, correct? So now this is the quadratic equation. Now I have to find out the root of this Vm. So what is actually the quadratic root of the or the root of this quadratic equation? It is nothing but what? It is nothing but minus b plus or minus square root of b square minus 4ac divided by 2a. So this is the root. This is the formula to find out the root. Now I'll use this formula. So therefore, what is Vm now? It is nothing but 2t plus or minus square root of 4t square minus 4k into 7200 d divided by 2k. So now I'll rearrange this term. That is, I'll split this term. So therefore, t by k plus or minus t by k whole square minus 7200 d by k. That is 2k will be squared and multiplied inside. So therefore I'll get this term. So now positive sign will not be used, because if I use the positive sign, then we will get the higher value of the Vm. So therefore only the negative sign will be used. That is, I have positive root and I have negative root. If I use positive root, then I'll get the much higher value of Vm. So therefore we will be using minus only. So therefore this is the formula to calculate the maximum speed. Okay, and also we can also calculate D. Okay, so this is the formula. Next, here when alpha and beta has to be calculated, if VA is known, then we can actually have this equation. That is, this equation we will have it again. 3600 D is equals to TVM minus half Vm square into 1 by alpha plus 1 by beta. Next, I'll rearrange this term, that is I'll transfer this term this side, that is RHS term will be transferred here and LHS term will be transferred over here. Next, if I rearrange that, then I'll get 1 by alpha plus 1 by beta is equals to 2t Vm minus 7200 d by Vm square. So we know that T is equals to 3600 D by VA. Yes, we know that. So, or VA is nothing but 3600 D by T. If I want T, then I can rearrange like this. We will substitute T in this equation. Upon substituting, what happened? We will get this equation. So next, let's multiply this term. So 1 by alpha plus 1 by beta, 7200 D, 200 D divided by VM VA minus 7200 D by VM square. Now you can see here 7200 d by Vm is constant. So if Vm square is constant, so if I take Vm square constant, then I'll get Vm by Va minus 1. So therefore, by using this equation, we can also calculate alpha and beta. So this completes the calculation, that is, if I want to find out the maximum speed and acceleration and retardation, then we can go for this derivation. So please remember that crest speed is nothing but what? It is the maximum speed. So next we have calculation by quadrilateral speed time curve. As I told you, this quadrilateral speed time curve will be used for the suburban services. Again, in the suburban services, whatever the curve we will get, so that is not in the proper geometrical figure. So now again I am going to simplify the obtained curve into a proper geometrical curve. So you can see here, so this is the quadrilateral curve for the suburban services. Okay, so usually what happen, OABC, what you can see, so this OABC is nothing but the actual speed time curve for the suburban service. Now what I'll do is, so now I'll extend this coasting period. So if I extend this coasting period, then I'll get the proper geometrical figure. You can see here OABC is the actual speed time curve, but that is not in the proper geometrical figure. Now what I'll do is, so now I'll extend this coasting period. You know that this is the acceleration period, and this is the coasting period, and this is the braking period. So now I'll extend this coasting period. So therefore I'll get the proper curve, that is OD into ODFC. Now, alpha is nothing but again acceleration in kilometer per hour per second. Beta c is nothing but coasting retardation. That is, in coasting also we are going to apply the retardation. That is, the retardation will happen. So therefore, that will be represented in BC, and unit is kilometer per hour per second, and beta is the braking retardation in kilometer per hour per second. V1 is the maximum speed at the end of the acceleration in kilometer per hour. Please remember that V1 is nothing but maximum speed or crest speed, and V2 is nothing but what? It is the speed at the end of the coasting period. So you can see here it is the speed at the end of coasting period. So next, total time of run is nothing but T1 plus T2 plus T3. And T1 is time for acceleration, which is nothing but V1 by alpha. And time for braking is nothing but V2 by beta. Then how do I calculate T2? T2 is nothing but T minus of T1 plus T3. Or you can see here, this is the speed by that speed by retardation, correct? So speed is nothing but what? Coasting speed. It is actually nothing but V1 minus V2, correct? It is nothing but V1 minus V2 divided by beta c is nothing but the time for coasting retardation. There will be two speeds in the coasting. Starting speed will be V1 and the ending speed will be V2. So therefore it is nothing but V1 is V2 divided by beta c. Now this is the curve I am having, and you can see here, so this is the V1. V1 is nothing but the maximum speed or crest speed. So in the exam they'll ask you V1 or V2. So you have to be very careful. If they ask V1, then we have to calculate for V1. Okay, so V1 is the speed at the end of acceleration, and V2 is the speed at the end of coasting, and this is T1, T2 and T3. Okay, so now total distance traveled D is nothing but what? It is the area under the curve or area under the quadrilateral ODFC. You can see here. So this is the area under the quadrilateral, which is nothing but ODFC. So what is this? This is nothing but area ODG. Now I can actually simplify again this quadrilateral curve, that is two right angle triangle and one quadrilateral. Okay, so this is nothing but area ODG plus area GDFH and plus area FSC. So what is area of triangle ODG? It is nothing but half into base into height. So this is half into height is nothing but V1, and base is nothing but T1 or T1 by 3600, which is nothing but T1 divided by 7200. What is area of trapezium? Trapezium is nothing but GDFH. You can see here. So this is the area of trapezium again. So it is nothing but half into base 1 plus base 2 into height. Okay, so this is or I can say in this way, this is base 1, base
x2 and this is the height. Okay, I can actually go with this. So therefore it is nothing but half. Base 1 is nothing but this is the v1 and this is the v2, and t2 is nothing but the height or width, I can say. Okay, so this is the thing. And upon simplifying, it is nothing but v1 plus v2 into t2 divided by 7200. Area of triangle FSC is again half into base into height, half into v2 into t3, that is v2 into t3 divided by 7200. So therefore D is nothing but adding of all these areas. Now I'll take, you can see here, I'll be splitting this term. Okay, so if I split this term, it is nothing but v1 by 7200 plus v1 into t2 divided by 7200 plus v2 into t2 by 7200. So now I'll split this term. So now what I'll do is I'll take v1 by 7200 as common from this term and this term. So therefore I left out with t1 plus t2, and here also v2 by 7200 is common, so left out with t2 plus t3. So we know that T1 plus T2 is nothing but T minus T3, and T2 plus T3 is nothing but T minus T1. So now I'll substitute over here. So you see here, have substitute that value. Next, I'll multiply this term. So therefore, V1 by 7200, V1 into T2, T by 7200, like that I'll multiply. So next what I'll do is, so I'll take T by 7200 as common. So if I take T by 7200 common, then I have V1 plus V2. And here these two terms remain same, and I'll replace T3 by V2 by beta and T1 by V1 by alpha. So next I'll take again V1 into V2 7200 as common. So therefore I have left out with 1 by alpha plus 1 by beta. So this is the formula to calculate the distance between the two stations. Okay. So now this is the equation 1. So we have V2 is equals to V1 minus beta C into T2. So where I have got this equation, we know that T2 is nothing but V1 minus V2 by beta C. So if I want V2, then what I'll do? So I'll multiply these two terms and I'll transfer these two terms this side. So therefore I'll get V2 is equals to V1 minus beta C into T2. So please remember here, so I'm now here, I'm deriving for V2. In the exam, if they ask the crest speed, then crest speed is nothing but the maximum speed, which is the maximum speed in this cut, which is nothing but V1. So there you have to derive only for V1, not for V2. And we have T2 is equals to T minus T1 plus T3, and I can substitute T1 is equals to V1 by alpha, and T3 is nothing but V2 by beta. So now V2 minus beta C, I'll substitute over here. Next, I'll multiply beta C inside. So therefore, I'll get this equation. Now I'll transfer this beta C into V2 by beta this side, and I'll take V1 common. So if I take V1 common, I'll left out with 1 plus beta C 1 by alpha and minus beta C into T. Now I'll take V2 common over here and I'll get this equation. So therefore, if I multiply cross multiply this term, that is beta minus beta C into B this side, so therefore I'll get this equation. So this is the equation for calculating the speed at the end of coasting. If I want V1, then I can rearrange in this way, that is V1 is equals to V2 minus beta C into T2. That also we can actually calculate. So this is the time trick. Okay, so solving equation 1 and 2, we can actually calculate distance V1 and V2. Okay, thanks for watching the video. Thank you.